today I'm going to present on SchemaCrawler. I just threw this slide up here. I currently work for Lytle & Company in Lowell, and we're hiring. So on to SchemaCrawler. SchemaCrawler is an open source project, and I think it is best described as a schema discovery tool. So what happens is that you go into a new company or you're a consultant and you're presented with this huge database with a large number of tables, each table containing so many columns. How do you make sense of that? You want to discover little bits at a time, and you want to do it your way, and you want to direct that discovery. Or you work for a company whose schema is constantly changing and you want to keep up with that. So you want the ability to be able to grep through your schema. I mean, you have excellent grep tools using regular expressions for files. Why not something for your schema metadata? That's what SchemaCrawler gives you. You can use SchemaCrawler to create database diagrams, ER diagrams, and combine that with the grep too. SchemaCrawler provides you a lint feature that's similar to C++ or Java lint, in case you're familiar with those. But this is lint for your schema design. Typical smells in your schema code design may be tables with a single column or tables with no indices and things like that. SchemaCrawler will point these out to you as potential problems that you might want to look at. You can infer table relationships. So sometimes DBAs don't allow you to create foreign keys between two tables for performance reasons. But if you have a strong naming convention, then SchemaCrawler can infer the relationships. It can use standard conventions like singulars and plurals, like the Ruby on Rails convention. It can infer common table prefixes that you might have in your schema, and you don't need to teach it. It learns your schema and finds these things out for you. And you can interact with your database using JavaScript or any other scripting language on the JVM. If you want to use JRuby or anything else, SchemaCrawler will give you a live database connection, and it'll execute your script against the database. So you can even drop tables if you wanted to. And finally, you can use standard templating libraries such as Velocity or FreeMarker to generate output. But SchemaCrawler does come with some output features built in, and we'll take a look at those. So the project was started about maybe 7 or 8 years ago. It was open sourced in 2005. It's been continuously maintained since then. And it is written in pure Java and pure JDBC. And what I mean by this is that pure Java, no other jars other than the JRE are required if you want to use the core functionality of SchemaCrawler. And by pure JDBC, I mean that it does not have a single line of database-specific code. That is, it doesn't use Oracle result sets. It uses the true promise of JDBC, and it is database independent to boot. It is open source and free, and it comes with a business-friendly LGPL, lesser new public license, so you can use it for anything that you'd like to use it. It is database and operating system independent. It's been tested on Unix, Mac, and Windows, and with a number of databases. In fact, it comes bundled with a number of database distributions. It's a command line tool, and it's also a Java API. So it offers you the best of both worlds. You can incorporate it in your regular Java project, or just drive it from Maven or Ant in your nightly builds, or as a command line if you're running it interactively. So there's multiple ways you can use SchemaCrawler. Installation is dead simple. You download the zip file and you unzip it and you're ready to go, assuming of course that you have your JDBC driver and you have a JRE installed on your system. That's all you need, because you don't need any other jars, you don't have any other dependencies. A large number of examples are provided with the distribution to allow you to explore the diagramming features, the grepping features, and so on, and the templating features. Everything, all the features of SchemaCrawler are showcased, Spring framework integration, and so on. And there are several database-specific versions that are pre-bundled. So wherever there's been an open source driver available for a given database, such as SQL Server or Postgres or MySQL, that driver is bundled with the SchemaCrawler distribution, so you don't have to download the drivers separately, except that most of these drivers come with a GPL license, which means that the bundled distribution then becomes a GPL download for you. Oracle and DB2 are not, there's no open source driver for those. So you can download the bundled version of Oracle or DB2, but then you go ahead and provide your own DB2 or Oracle JDBC drivers. And finally, you need this third-party, again, open source and free graphing library called GraphViz that you can download and install on either Linux, Mac, or Windows. And SchemaCrawler seamlessly interfaces with that to produce database diagrams as PDFs, PNGs, and whatever other output formats GraphViz supports. Now, if you're using the Java API of SchemaCrawler, if you've ever used plain old JDBC to get database metadata, you know what a pain it is. You've got to deal with result sets when you're getting database metadata. You've got to deal with closing your resources and managing your exceptions. And you've got to deal with idiosyncrasies like, what is a Boolean? Is it a 1? Is it a yes or a true? And all of these are available in various places. Sometimes you even get a null for false. You know, it's absolutely insane. There's no consistency in the JDBC API. SchemaCrawler gives you everything back as a POJO, and it is extremely consistent. It uses enums. We live in a post-Java 5 world. I don't think JDBC found that out, but SchemaCrawler knows about Java 5 enums and Boolean values and so on. So here's an example of, of your typical, you know, the ease of use of SchemaCrawler. This is sample code that shows you just how easy it is to get to your database metadata. You use standard Java idioms here. So segueing into the SchemaCrawler command line is, you know, it works just like any other Unix or shell command. You type sc and you get help. And you can get more detailed help on specific SchemaCrawler commands. What you do need to provide if you're connecting to a database is you need to provide your connection parameters in the standard way. And you need to provide an information level which determines how much metadata you want to obtain from your database. I'll demonstrate all of this using some real examples. And finally, you provide your SchemaCrawler command that you know, describing what you want to do. Here's an example of some of the commands. SchemaCrawler produces plain text and HTML output. Both of these are designed to be diffed using a standard diff tool. And you can keep track of your schema changes over time. As you know, if you ran this in your nightly build, you can keep track of your schema changes. You can use this to diff your production database versus your development database and find out exactly what the differences are. If anybody's tried to diff you know, SQL, DDL, you know, it can be mind-boggling to figure out exactly what column has changed what data type, but SchemaCrawler makes it easy. So I'm going to go into some examples, and the examples are going to cover exactly what details SchemaCrawler can provide you. So what I've got set up here is I've got a virtual machine with SQL Server 2008 and Microsoft's open source AdventureWorks OLTP database. And we're going to go against this in our example. So you open a command prompt pointing into your SchemaCrawler unzipped distribution, and you can go from here. You start off by just typing sc, and you get help. Okay, so you can see all kinds of options here which you can use. If you want help on any specific command, you can do that too. So you can say I want specific help on the graphing command, and you can get that. Now, let's say that you just wanted to go in and you wanted to start exploring your database. You wanted a list of all the tables in your database. So you would use a command line like this. Can everybody see this command line right at the back too?
Is anyone can increase the font?
Yeah. Is that better? A little more? Okay. So what we've got here is you've got your basic connection information. You've provided your username and password into the database. You've specified what database you're going against. And because this is the bundled version for SQL Server, it generates the database URL automatically for you internally. It knows how to do that. And then you notice over here, you're using standard regular expressions. Now, I'm not the regular expression guru, but I found this on Google using a Google search. What it's saying is, go to AdventureWorks and get me all schemas that are not the sys schema. So it looks pretty complicated, but if you use regular expressions, this should be relatively simple. It just demonstrates the power of SchemaCrawler. And your info level is minimum. You don't want to waste too much time getting database information because all you're doing is getting a list of tables. So I'll show you what this output looks like. I've pre-canned the output, and it's going to look like this. So you're going to get some basic information about your database, and then your connection information. SchemaCrawler is really careful not to output your password for security reasons. And then you get a list of tables. A view is also considered to be a table. You can filter all these things out on the command line. So you get the fully qualified name of your table. Then let's say you wanted to go and get some more details about your schema. So you would say, I want to focus on tables related to products. I'm not interested in anything else. So I'm going to make a guess. I don't know anything about this schema, but I'm going to go and make a guess. And I'm going to say that the table name starts with the word product. And that's going to be a product table. So I construct a regular expression with a minus tables. And I say, get me any table in any schema that starts with the word product and ends in anything else. So this regular expression has to match the fully qualified name of your table. And SchemaCrawler is going to automatically go and find that out for you. And it's going to give you output like this. So you notice the one thing common in all these tables is that they start with the word product. And you notice that some of them belong to other schemas, like the last one at the bottom here belongs to the purchasing schema. But you kind of get the idea that purchasing, yes, it sort of probably needs something of the product information. So, you know, a product vendor would be in the purchasing schema. So now in an unknown database, you've kind of tried to find out what, you've kind of narrowed down, and you've narrowed down your product domain irrespective of what schema it belongs to. Then let's say you want to go in and you say, okay, now that I know that I'm going to go against my products, I want a little more information about these tables. So you change your command to command schema, and you change your info level to standard, which gives you a little more information. And the little more information that you get there looks like this. So you get the details of every column and every data type. It is possible to produce this data type information in a database agnostic way. So this is in a database specific way. This looks like SQL Server data types. But let's say you wanted to compare the schema to an Oracle schema. SchemaCrawler could generate this in standard Java data, SQL standard data types, that you could do that comparison also. And then you have foreign key and primary key information. You have index information and all of these good things. And it tells you what kind of foreign key it is. So this is the information that you get with your standard schema. Now, let's say that you wanted to archive this. So you wanted to take this information and output it to HTML. So you would run a command like this, except you would say the output format is HTML. The HTML output format is pure XHTML. In other words, it's a fully valid XML document also, but it works equally nicely in the browser and makes it a little bit more readable. It's the same information though. So you would get a little bit of color coding and bolding, but essentially you get the same information. Now let's see how much detail you can get. So So we want to go into this one single table. So we've said tables, I just want the work order table, and I want to get the maximum possible information, which is the details. And I have to use an info level of lint, which gives you every possible thing about this table. And you can see that, that what you're going to get, in addition to everything that you got before, you're going to get check constraints on the table, including the actual source of the check constraints. You're going to get all your grants and privileges. You're going to get your triggers, including your source code for the triggers. And you can take all this information and then you can use, you can save it to a file, you can use it as a reference, you can throw it up on an internal wiki or whatever you need to do with it. SchemaCrawler is not necessarily limited to schema metadata. You can do counts. So let's say you wanted to quickly go and get counts of tables. You could do that. Empty tables are highlighted not as 0 rows but empty so that they stand out. You can get full data dumps. So, SchemaCrawler is capable of doing a select into your table and outputting all that data into a text file. By default, it's in a CSV-like format, but it can also do HTML. And that output looks like this. So that's what a table would look like. So right now we've been talking mainly about tables, views, and so on, but you can also get procedure information. So you can get, you just say tables equal to nothing, which means no tables. And since we've not said procedures equal to nothing, it's going to now not do the tables and do the procedures. You could do both together as well. So that's your full procedure information. You get all the input and output parameters. You get the source code of the definition of the procedure. And finally, the most interesting feature of SchemaCrawler is the diagramming feature. The diagramming is generated from the command line. So unlike your traditional ER tools where you point it to a database and you have to decide what tables you want to do, wouldn't it be so cool if you could say, hey, I want this, all the product tables, I don't know which tables I'm talking about, just find me all the tables that start with the word product, or find me all the tables that have a column with this name, and output them into a diagram. So I don't know what tables I'm talking about, just do it. And that's what SchemaCrawler does, is it says, find me all the columns, all the tables that contain a column called customer ID. There might be hundreds, there might be 20, there might be, I don't know. Anything that contains customer ID, that's the table I'm interested in. Put it in a diagram and show it to me. And this is live. So as your schema changes, you don't have to go to the DBA to generate an ER diagram. You don't have to regenerate the ER diagram. You just run this command over again. It literally takes a few seconds, and it produces a PDF file, or a PNG file, or any other kind of file. With the help of GraphViz, you get a diagram like this. Now, I just want to point out a few interesting things in this diagram. The schemas are color-coded. So all the tables that we found belong to a certain schema. And all the tables that matched are shown. The tables that did not match are shown over here. So what this is indicating is that, yes, we did match a table. This table had some foreign key relationships that I think you should know about, but the tables that are linked to it did not match the grep expression, but I just want you to know about it. And also what SchemaCrawler has done is that it's tried to infer a relationship between tables, and it shows inferred relationships in dotted lines. So you see here that it has inferred, you see there's a foreign key from here to here and there to there, but actually SchemaCrawler thinks, yeah, maybe there's really a foreign key all the way back there. And there doesn't even have to be a foreign key relationship. It can just do a name and data type inference. And finally, JavaScript. So you can write a really simple JavaScript or Ruby or any other language, and you can do things with it. You can do almost anything that the scripting language allows you to do. So I'll show you an example of what the JavaScript might look like. So this is going to be our JavaScript. What SchemaCrawler gives you into your database context is a live database connection and a schemas object. All of this is documented on the Java docs. So if you're not sure what properties to use, you can look at the Java docs. But what we're doing is we're essentially looping through our schemas and outputting some data. And when you run this JavaScript using the command at the bottom here, you tell it what JavaScript file you want to run, and you're going to get output like this. This is exactly what a JavaScript wanted to do. And since you have a live connection, you could run selects, you could drop tables, you could do whatever you wanted. So essentially that concludes the brief overview of features. So thank you, and I can take a few questions maybe, or you can meet me outside if you think of something later. So, okay, thanks.